Again, hello, welcome to my first lectures on statistics. In this lecture, I'm going to cover the theoretical aspect of statistics, for example, the definition of it, and I will explain the reason why statistics is very important. Almost every major in college or university takes statistics as a general requirement. So let's start the uses of statistics. Here we say statistics is one of the tools used to make decisions in business. Also, we can apply the concept in our life. And as a student of business or economics, it's very important that we have the basic knowledge of statistics and also the skills to organize, analyze, transform, and present data. So actually the definition of statistics is the process of first, how to collect the data. Second, maybe the storage of the data. Most important nowadays, our data analysis or in statistics, we are using computers now. So collecting data, we have to know how to store the data in a computer system, for example, in a database system. From there, we should use the statistics techniques to again organize this data, possible analyze the data, transform the data, then present the data. When we say present the data, we mean, for example, if we have a business organization, maybe the management can make a decision based on the outcome of the data result. For example, we may analyze a marketing product or a customer from different regions. We collect the data of customers from different regions, or let's say different states. We store this data in a computer system. If it's not already in the computer system, then we are going to use a software which normally runs statistics methods or techniques. Then we analyze, then we come up with a decision. The outcome of the process, again, management can use that to make a decision, whether in New York State, the customers are more profitable, or customers between the age of 20 to 30 like to buy product A than buying product B, or a customer that make over $100,000 income annually likes to buy product that costs more than $2,000, etc. So that's one of the examples of the use of statistics. Actually, statistics also go with data analysis, because the concept of statistics is collecting data, organizing the data, and also analyze the data. And here we say the reason why we study statistics is because data is almost everywhere, especially numerical information is everywhere. When we say that numerical information, we mean data, for example, the age of a customer, the annual income of a customer is a value. And also the techniques are used to make decisions that affect our daily lives, especially in the field of, let's say, banking industry or retail. Yeah, most likely we are going to analyze data from our customers' behavior. When I say behavior, I mean the business pattern that our customers do. Most likely we have to analyze it, so that either we have to improve on the service that we give to them, or maybe we have to maintain it. So the knowledge of statistics methods will help you understand how decisions are made and give you a better understanding of how they affect you. So who uses these techniques? I would say almost every major professional fields. Example would be sports, professional sports people like NBA league. They take the data from the game, how many scores so player scored, and how many fouls he made, how many So there are so many. So all the activities that goes on, let's say in a basketball game or baseball, data can be collected. And also when we visit the supermarket buying products, this is the data also that is generated. When we use our credit card online and doing any transaction, the company generates data. Actually, when we use our cell phone to even communicate, it tends to electronic data. And most of these data are stored in the cell phone subscribers server system. So here we say the stats techniques are used almost in marketing, accounting, quality control, consumers, professional sports people, even hospital administration. So the list keep going. So almost every field of studies. So we have two types of statistics. One is called the descriptive, and one is called inferential statistics. Most textbooks you will see always have been teaching statistics for about 10 years. Always we start with the descriptive first. Descriptive tells us, for example, how to organize our data, let's say using a graph, or let's say frequency distribution table, stem plot. And we have so many different types of charts. Or I want to understand my data. So maybe the central tendency, finding the mean media mode. We shall go through all this in the coming lectures. So this is descriptive. Then we have inferential statistics. Our main goal is that we have a population. We are going to take a sample from this population, and then we are going to analyze this sample data. And the decision that we get from the sample data, we are going to represent it to the whole population. So let's say in New York State, we have over 12 million people, population 12 million. And let's say male adults, let's say it's only 4 million or 3 million. And now I want to maybe do a research, or let's say I want to know the median income of adult male between the age of 30 to 60. Well, if the population is 1 million, I don't want to take all my time to get all the data from the 1 million, how much is their income, to find the median income. So most likely I'll take a sample of only 100 or 200 out of 2 million. So when we are taking a sample, we have to be very careful. We have to make sure that the data, there's no innate bias. The sample represents the population. We may discuss this also when we reach inferential statistics. But the first, let's go through the definition. Descriptive statistics is a method of organizing, summarizing, and presenting data in an informative way. So example of organizing data, we can use a chart. We can use a table to organize our data. Summarizing the data, maybe we want to understand the data, let's say the location of the upper or lower values, or location of any specific value, which we can find the quartiles, or if there's any outline in the data set, or we want to find the standard, let's say standard deviation. Standard deviation will tell us how the data varies. For example, if I have 20 employees and all the 20 employees makes the same amount of salary, let's say $30,000 a year. If I'm looking for standard deviation, the answer will be 0. Why? Because there's no any variation between all the salary. All the employees are making the same salary. Now, if they are making different salary, let's say between 20,000 to 10,000, we will get a standard deviation specific value. Now, if it's between 20,000 to 2,000, the standard deviation will be bigger than if it's between 20,000 to 19,000. So we can find how the data varies, the location, the central or tendency of the data, etc. All this is descriptive statistics. An example is given here. If there are a total of 46,837 miles of interstate highways in the United States, we have 46,837 miles of interstate highways in the United States. The interstate system represents only 1% of the nation's total roads, but carries more than 20% of the traffic. The longest is I-90, which stretches from Boston to Seattle. The distance is almost 3,100 miles. So again, this is the concept of a descriptive statistics. And here we say average person spend $103 on traditional Valentine's Day merchandise in 2013. This is an example of descriptive statistics. Actually, in this example, we are looking for the average or the mean. So we are going to add all the, let's say if we take only a sample of 20 people, we are going to add how much money each one spent for the traditional Valentine's Day merchandise. Each person, we add the value, then we divide by the number of values, and that will give us the average. Now, as we said earlier, inferential statistics is about decision making. So a decision, estimate, prediction, or generalization about a population based on a sample. So we have to take a sample from the population. Then we can analyze it. For example, when we say a prediction, we can use something like a regression analysis and generalization concept, decision, estimate. We will cover all these topics. So an example here say in statistics, the word population and sample have a broader meaning. A population or sample may consist of individual or objects, but a population means everything. A sample means part of the population, or we can say a subset of the population. Population is a sample, so the same thing. So population is a collection of all the possible individuals. So population is a collection of all the possible individuals, or any objects, or any measurements of interest. Then a sample will be part of the subset of the population. So when we look at the diagram here, we can see that we have where market size a box, a big rectangle or square box, and we can see that it's very big. And we have some items inside. Now, all the items is a population. Now, if I take only 6 out of the total item should be around 30 here, 30 items. Now, I want to do analysis. So we decided to take only 6 out of the 30. So the big box will represent the whole population, and the small box will represent the sample. So they say, why take a sample instead of using the population? Which really is very interesting, because when we use all the population, we will get the accurate result. Accurate, because here we are using all the population. Sample, we may get close. That's why we do estimate, confidence interval. We may get something closer to the accurate, either less or greater. We will be very lucky to get exact amount as the population. So there will be some, but our goal is that we want to minimize the error, the difference. But the main reason why we need to use sample instead of population is that population is very expensive. If I want to take a sample of all population, it will consume a lot of time. And not only time, if there's a financial, we have to pay the people involved, the staff taking or we have to use more materials. So we say the cost is the main reason why we need to use a sample. So if I want to do a survey or a study on US population, we have almost 300 million here. I can't take, it will be a very time consuming to take all the data from 300 million people. But maybe we have 51 states, somewhere 50 or 51 states. I may decided, okay, I'm going to take 100 from each state. So we end up getting like 5,000 or less than 6,000. So we can manage that using 300 million. So this is the main reason why we use, again, sample instead of population. But we know population weights will give us the accurate result. So using a sample to learn something about population is done extensively in business, agriculture, politics, and government. I would say the only study I can tell, or one of the few study I can tell that we don't use a sample is maybe when we are taking the census of a population. In this case, we want to know the total number of people living in a specific country. Maybe we may take each person, citizen, we may try to know their income, their behavior in terms of where they are living, medical care, etc. So census, in terms of census, we have to take the population because we want to study the whole country population. And one of the main reasons of taking census is to know how many people live in a specific area or a country. So now in statistics, we have something called variables. And we shouldn't, it's almost, I would say it's almost close to college algebra when we use the term variables also. In college algebra, variable means unknown value. So we can represent it by any character, let's say X or Y or Z. And in the process of trying to find that value, it can change based on equation, etc. In statistics, variable also means something like that, but variables here means the attributes or the characteristics of an object. So for example, if I'm taking, let's say, a data on a student, maybe student ID or student name is a variable. So those are the characteristics. Like example here, we have different types of variables. So here we talk about qualitative variable. Here, qualitative means it doesn't carry a value. It will carry something like a test or here we use the term non-numeric. So example would be gender. Gender can be male or female. We cannot say a gender can be 20. Religious affiliation cannot be 60. They have to be either Christian, Muslim, etc. Type of automobile owned, it cannot be a value. So again, qualitative or attribute variable is the characteristics of being studied is non-numerical. So if I'm studying an income is quantitative variable because income is value. Information is reported numerically, so it's a value. So example here can be the balance in my checking account, how many minutes it takes me to walk from my house to school, number of children I have in a family. But type of automobile that I own, I cannot give it a value. Even the state of birth, but date of birth can be quantitative. It's a quantitative. So now qualitative variable classification, we have two types. We have what we call the discrete variables and we have continuous variable. Anytime we hear the term discrete, distribution variables, so we mean whatever information we have, it based on a counting. There's usually a gap between. So for example, number of children I have, it cannot be 1.66667. The number of children have to be 1 or 2 or 3 because we count it. And number of, example here is the number of bedrooms in a house cannot be 1.2. You have to be either 2, 3, 4, etc. Now we also have continuous variable. Continuous variable can assume any value within a specific range, but again, it's based on measurement. So for example, I can use a scale to find the weight of a pork chop, or we can find the height of a student in a class. So these are the two, again, different types of discrete variables, continuous. The shortest way to say this is that discrete variables is based on counting and continuous variable is based on measurement. So this is a summary of types of variable that we may come across as we go through this course materials. Types of variable can be first qualitative or quantitative. In qualitative, let's say the brand of a PC, hair color, marital status. Marital status cannot be 20, 30, 40. You have to be either you marry or you divorce or you are single. Then in quantitative, qualitative, we have only one. It's qualitative. But quantitative, since we can have, quantitative is based on values. But since we can have a value by counting or a value by measure based on measurement, we divide it into two. So we have the discrete, then we have the continuous. So discrete is based on counting how many children in the family, how many strokes on a golf hole, how many TV sets at home. So everything is counting. Now in continuous measurement, amount of income tax paid, weight of a student, yearly rainfall in Tampa, Florida. These have to be measured. So again, types of variables are qualitative, which is normally non-numerical values. Then we have quantitative, which is numerical values. By quantitative, it's a numerical value, but we can get the value on two ways, either by counting or by measurement. Counting means discrete, measurement means continuous. So now we know the type of variables we have. Now we are going to go through the levels of measurement. Now, when we say the levels of measurement, we mean, for example, let's start with the variable. I have a variable named gender. Now, I want to measure what consists of gender, and that's the level of measurement. So, for example, gender may have a nominal level, because nominal level are data that is not numerical. So example will be high color, gender, religion. So nominal level, I'll say it's the same as qualitative. Then from there we have ordinal level. Ordinal level means something is in order. Actually, that's why it's called ordinal level. The data will be in order. The data will be in order. So example, in grading, we have first, second, A, B, C, D. In sports, and let's say running, we have first place, second place. These are in order. Then interval level is similar to ordinal level, but this time we can do an arithmetic operation, let's say addition, subtraction. And also zero does not mean nothing. Zero means something. For example, a temperature. When we say a temperature equal to zero, it means it's very cold. But when we say my balance, let's say my bank account balance is zero, it means I don't have nothing. So bank account will be a ratio level. So ratio level is the interval level with an inherent zero starting point. Because if my bank account is zero, it means I don't have anything. And the differences and ratios are meaningful for this level of measurement. So example can be my monthly income of soldiers, or distance traveled by manufacturing representatives per month. So we have 4 levels of measurement: nominal level, then we have ordinal level based in order. Nominal level means non-numerical value. Interval level means zero, doesn't mean nothing. There's no natural 0 point. Then ratio, there's a natural 0 point. So the level, the interval level with an inherent 0 starting point. So normally we already talked about this. So nominal level data, the properties again, observation of qualitative variables can only be classified and counted. There's no particular order to the labels. Then other level data, very important, there is in order. You can see example here will be the Homeland Security Advisory System. We have from low to severe, so it's in order from low to guided to elevated to high to severe. So data classification are represented by set of labels or names. High, medium, low is in order. Then interval level data classification are ordered according to the amount of characteristics they possess. So equal differences in the characteristics are represented by equal differences in the measurements. And the only unique difference here is that 0 is something, and always use the temperature as an example. The ratio level is almost practically everything. All the quantitative data is recorded on the ratio level of measurement or the quantitative data. So ratio level is the highest level of measurement. Data classification are ordered according to the amount of characteristics they possess. Equal differences in the characteristics are represented by equal differences in the numbers assigned to the classifications. The 0 point is the absence of the characteristics, and the ratio between two numbers is meaningful. So here we say, why is the level of measurement important? The level of measurement dictates the calculation that can be done to summarize and present the data. So for example, if I have a variable, let's say an attribute of a customer, let's say we have height. Yeah, I can find the average height of all the customers, or weight, or income. I can find the average. So this is quantitative. And based on, because I can do almost any calculation, is ratio level. Now, if I have the same, let's say customers or patients, let's say customers, and this time we want to know, example be, let's say the color of their eyes. This will be, can be brown, white, blue, any color we can think of. But can I add colors? Can I find average of the colors? No. So this is nominal. So automatically I'll say the only thing I can do is counting or finding the mode. How many customers, eye color is black, brown, yellow. I can't find the average, but I can find the counting. So this is why level of measurement is important. So this is the summarization of the level of measurement. So we have level of measurement. As I said, we have 4 types: nominal, ordinal, interval, and ratio. The nominal, the data may only be classified or counting. So example they gave here, the make of a car, or jersey numbers of a football player. I can't find the average of a jersey number of football players. It's just that I can count it, okay. In this game, we have 2 players whose jersey number is 23. But I can't say 23 plus 23 divided by 2 will give me 23. So the average, no, we cannot. So that's nominal. Ordinal means something in order. So data are rank. Your rank in class, then a team standing in a, let's say, an NBA game, or this case, at 10. Now, interval mean differences between values. Temperature, the dress size is a very good example also. So the dress size, we can't just say 0. And if it's 0, it means something. It doesn't mean nothing. Then ratio is almost everything. So meaningful 0 point and ratio between values. So the number of patients, number of cells, calls made, distance to class. Almost in every field of studies, we always talk about ethics, because ethics is very important. How, again, you are honestly representing your company, doing the right transactions, no fraud. And so ethics, and also the guidelines, no respect to all customers, employees, etc. So the practice of statistics is the same. We have to consider the ethics. But ethics here also doesn't mean respecting, but also it means the job you are doing, are you doing it in the right way? Are you honest with what you are doing? So in statistics, I can collect a data and maybe I know I'm trying to be very quick. I didn't follow the right track to validate the data, etc. Or maybe I may change the values in the data set so that I may get a result that is presentable to the management. When I'm saying presentable, I mean it's very, it will make them basically meet the objective. So that's the end of this lecture. Again, in this lecture, we didn't do anything in terms of mathematics or statistics techniques. This lecture only tells us the reason why we should learn statistics, and also what is statistics, and also how many different types of statistics techniques or method we have, etc. So again, see you in the next lectures. Thank you.